working on a physics project. Oh, this shape looks like a donut. That's like what you are eating. What? My donut? Yeah. What are you talking about? Well, we are talking about Tokamak. What is Tokamak?
Tokamak is a device designed to confine a high-temperature plasma using magnetic fields. It is to sustain nuclear fusion reactions similar to those that power the sun. It is one of the most developed and promising approaches for achieving controlled thermonuclear fusion for power generation.
Component of tokamak consists of a vacuum chamber, which is a sealed donut-shaped vessel where the plasma is generated and confined. This is to maintain a low-pressure environment. The second component is plasma. Plasma is an ionized gas made up of light elements that are heated to extremely high temperature, which is 100 million degrees Celsius and above. The third component is the heating system. The heating system has ohmic heating, which is an electrical current is passed through the plasma, heating it via resistance. The second one is neutral beam injection, which is a high energy atoms are injected into the plasma, transferring their energy. The third is the radio frequency heating, which is an electromagnetic waves heat the plasma particles. And the last component is the cooling system. The cooling system manages the heat generated by the plasma as superconducting magnets. Now we move on to the magnetics component in the tokamak. The first component is the toroidal field coils. It is functioned to produce a magnetic field that runs around the donut shape in a toroidal direction, which has shown in the picture. These are large electromagnets arranged around the vacuum chamber. Second component is the poloidal field coils. It is positioned around the outside of the torus. It is to generate magnetic fields that control the vertical position and shape of the plasma, just like in the picture shown. The third component is the central solenoid. It is located at the center of the tokamak. It acts like the primary coil in a transformer to induce current in the plasma. And the last component is the plasma current. The plasma current is the induced current in the plasma itself, generates an additional poloidal magnetic field. This field interacts with the toroidal field to create the helical magnetic field structure necessary for confinement.
An electric current is passed through the vessel, breaking down and ionizing the gas so that the electrons are stripped away from the nuclei, forming a plasma. The energized plasma particles collide and heat up, while auxiliary heating system increase the temperature to the required level for fusion, 150 to 300 million degrees.
Type of magnet that used in tokamak is superconducting magnet.
Why magnetism is essential for the operation of a tokamak? Magnetism is absolutely essential in a tokamak because it is the only method to confine and control the high temperature plasma required for nuclear fusion. The fusion process in a tokamak heats plasma to temperatures exceeding 100 million degrees Celsius, far hotter than any solid material can withstand. What would happen if these magnets were not present or failed? If magnets were not present or failed to function properly in a tokamak, the plasma would immediately lose confinement and come into contact with the reactor walls. This will cause the plasma to rapidly cool down. These are the several key features of the tokamak depend directly on magnetic properties. And these are the magnetic systems to improve tokamak.
Next, real-world examples of tokamak usage is which is experimental advanced superconducting tokamak. In China, this tokamak broke records by sustaining high temperature plasma for long periods, simulating the conditions necessary for future fission power plants. It is also called the Artificial Sun, is a fission research facility in Hefei, China. It aims to copy the sun's process of producing energy by heating hydrogen atoms until they fuse into helium, releasing a large amount of energy. The key points is uses superconducting magnets that can carry strong electricity with almost no energy loss. Second, it can reach over 160 million Celsius, much hotter than the sun's core, which is needed to make fission happen. And last, in 2021, it kept the hot plasma stable for 1056 seconds, almost 18 minutes, a world record at such high heat. The significance of using magnet in this device and its impact on technology or society, magnetic confinement.
Tokamaks use powerful magnetic fields to confine and control the hot plasma. Without magnetic confinement, the plasma would melt any physical container.
Technological advancement.
Benefiting other fields like medical imaging, MRI, particle accelerators, and advanced electronics.
And impact on society.
If fusion becomes a particle energy source, tokamak reactors could provide nearly limitless, clean, and safe electricity.